Hello everyone, welcome to day 2 of box and whisker plots. Today what we're going to do is be analyzing some box and whisker plots that are already created for us. So just as a quick review from the previous lesson, remember there are 5 statistical measures that we can easily read from a box and whisker plot. The box shows the middle 50% of the data and the whiskers show the first and last 25% of the data. So in the previous lesson, we talked about how there are these 5 critical values: the minimum value, the lower quartile, which we also call the first quartile, the median, the upper quartile, which we also call the third quartile, and the maximum. Those are our 5 critical values that we need in order to create a box and whisker plot. And we also talked about how there are 4 sections on the box and whisker plot, and each of those 4 sections represents where 25% of our data lies. And so if you're looking at the boxes together, that's 2 sections, so that's 50%. Okay, so let's look at example 1 and answer some questions. Example 1 says, Mr. Webster surveyed the students in his first period gym class to find out how many times they exercised this month. The box and whisker plot below shows the results. So the first thing we're going to do is state the minimum of this box and whisker plot. And so that is our very first point, which in this case is at 0. Our first quartile is where we have the beginning of our box, and that's at 5. The median is our third point, or the middle of the boxes. That's at 10. The third quartile is the end of the box, or our fourth point, which is 20. And our maximum is the last point, or the highest point on our box and whisker plot, which is 30. To find the interquartile range, and this is also known as the IQR, you'll hear me use that abbreviation. The interquartile range is when we take our third quartile and subtract our first quartile from it. So for our third quartile, we had 20, and our first quartile was 5, and so our interquartile range, or IQR, is 15. To find the range, remember that's taking our highest number minus our lowest number, or our max minus our min. So our maximum was 30, and our minimum was 0, giving us a range of 30. Number 8, what percent of the data falls between 0 and 5? So looking at your box and whisker plot, we can see that 0 to 5 is one of our whiskers. And because it's one section out of the 4, that represents 25% of our data. In number 9, it's asking what percent of the data falls between 10 and 30. Well, 10 to 30 includes a box and a whisker. So 2 sections of that box and whisker plot, which makes 50%. Number 10, what percent of the data falls between 0 and 20? So from 0 to 20, we have a whisker and 2 boxes, which is 3 sections. So if each section is 25%, 3 sections is 75%. Number 11, state an interval that contains 25% of the data. So we've already said that 0 to 5 is 25% of our data because it's one of the 4 sections. So we just need to choose another. We have 3 other options. We could say the interval of 5 to 10. We could say 10 to 20. Or we could say 20 to 30. Those are all intervals that contain 25% of our data. So I'll just go with 5 to 10. Number 12, state an interval that contains 50% of the data. So we've already used 10 to 30 in number 9 for 50%. And so we could do the first half of our data, 0 to 10. That would be 50% because it contains 2 of your sections. So I'll go with that. You could have also said from 5 to 20. That would be another 50% section. Anything where it's 2 parts of your box and whisker plot together. Okay, number 13. If there are 20 students in the class, how many exercised more than 20 times this month? Okay, so now we're talking about actual number of students versus percent. So if we know that there's 20 students in the class, I need to figure out how many students exercised more than 20 times this month based on what we can figure out from the box and whisker plot. So the first thing we want to look at is what percent of students exercised more than 20 times this month. So if I go back up here, it looks like 20 or more times is my whisker at the end, so that's 25%. So what I need to do is I need to figure out what is 25% of the class. And in this case, there's 20 students in the class. So I can do this a couple of ways. I can think of it as part over whole. How many students out of 20 is 25%, so 25 over 100, which if I'm doing it this way, I would cross multiply, and then I would divide by 100. I would get 5 students. Okay, another way you might do this is to think, well, 25% is the same as 0.25. Of means to multiply, and so I could multiply 0.25 times 20, and I'd also get 5. So that's just another way that you can get the answer. Okay, number 14. If there are 20 students in the class, how many exercised between 5 and 20 times this month? So going back up to the box and whisker plot, 5 to 20, this is 2 sections of our box and whisker plot, which means 50%. So I know that 50% of the class exercised between 5 and 20 times this month. So I need to know, what is 50% of the class? What is 50% of 20 kids? Now some of you will be able to do that in your head because you know 50% is a half. If you wanted to show the proportion, I'm working that out right here. Okay, so half of the class would give me 10 students. Okay, let's go to example 2. So this box and whisker plot shows the ages of Mr. Finn's grandchildren. And question 1 says, how old is Mr. Finn's oldest grandchild? So based on our box and whisker plot, we're looking at the maximum to get the oldest grandchild, which looks like 25. Number 2, how old is Mr. Finn's youngest grandchild? So that is the minimum, which looks like 11. What is the range of the grandchildren's ages? Okay, so remember, range is when we take the maximum minus the minimum, highest minus the lowest. So we just found the oldest is 25 and the youngest is 11. So the range is 14. What is the interquartile range of the grandchildren's ages? Okay, so to find the interquartile range, we take the third quartile minus the first quartile. So the third quartile, remember, is the end of our box, which in this case would be 22. And the first quartile is the beginning of our box, which is 16. And so the interquartile range would be 6. Number 5, what percent of his grandchildren are between 16 and 22 years old? Okay, so 16 to 22. That includes both boxes, or 2 sections of the plot, which means it's 50% of his kids, his grandkids, are between that age range. If Mr. Finn has 12 grandchildren, how many are between ages 16 and 22? Okay, well, we just said 50% of his grandchildren are between those ages. And so what I'm doing is I'm finding out what is 50% of 12 of his total grandchildren. And we know from the previous example that we can just divide that by 2 to find 50%. So 6 of his grandchildren. Okay, example 3. Now we're looking at a double box and whisker plot, which is really just two box and whisker plots on the same number line. Okay, so the double box and whisker plot below shows the number of points scored in games by two basketball players on the same team. So we have Missy and Louisa, and number 1 says, which player has the higher median points scored? Okay, so remember, to find the median, we are looking in the center of the boxes, kind of right here. Okay, so I can see that Missy has a median of 13, and Louisa has a median of 12, and so that would mean that Missy has the higher median. Number 2, which player is less consistent in their points scored as determined by the range? Okay, so in order to figure out the range, I am going to take the highest number minus the lowest number for each girl. Okay, so let's start with Missy. So Missy's highest is 18. Her lowest is 0. And so her, that doesn't look right. 18 minus 0 would be 18. Louisa is going, let's see, 17 is her highest, 10 is her lowest, so her range is 7. So the question says, which player is less consistent? So I want you to think about this. Consistency depends on how spread out the numbers are. So the bigger the range, the less consistent the player. Okay? Because Missy's range is 18, that means that her points scored is very inconsistent. Okay, so she scored in one game 18 points, and another game 0 points, and everything in between. Where Louisa, her range is smaller, meaning that she is more consistent in the points that she scores in the game. Okay, so who is less consistent? We're going to say Missy. And again, that's because her range is bigger. Okay. Number 3, Missy's maximum number of points scored exceeds Louisa's by how much? Okay, so maximum points scored for Missy is 18. Maximum points scored for Louisa is 17. So Missy's maximum score exceeds Louisa's by 1 point. Okay, last one for this. Missy's first quartile is the same as what critical value on Louisa's box plot? Okay, so Missy's first quartile is right here at the beginning of that box, and that is the same as, if I look on Louisa's plot, it's the same as Louisa's median. Okay, so the median for Louisa is 12, and so is Missy's first quartile. All right, we have 2 more examples to go here. Example 4. The double box and whisker plot below shows the weights in pounds of Labrador Retrievers and Cocker Spaniels from a veterinarian's office. So we have the dog's weights in pounds, and then we have our double box and whisker plot. So based on the range, which dog breed has weights that are more consistent? Okay, so let's find the range for each. So I'm going to do Labrador Retrievers and Cocker Spaniels. So for the labs, it looks like 70 is my highest weight, 45 is my lowest, giving us a range of 25 for the labs. For Cocker Spaniels, it looks like the highest weight was 30 and the lowest weight was 15, and so that range is 15. So when they're asking you who has weights that are more consistent, remember, the smaller the range, the more consistent. So in this case, Cocker Spaniels definitely are more consistent consistent in their weights because they only vary by a range of 15, where labs range is 25. Okay, number 2, Mrs. Hayward has a Cocker Spaniel who weighs 30 pounds. Which critical value on the box and whisker plot is 30 pounds? Okay, so true story. I think my Cocker Spaniel is probably about 35 pounds, but close enough. So the critical value would be the maximum point, right? It's the highest of the Cocker Spaniels. Number 3, Mrs. Hayward used to have a chocolate lab who weighed 125 pounds. How much more did her lab weigh than the maximum weight from the box and whisker plot? Again, true story. I think at one point he was closer to 130, 135. So we'll go with 125 though. So in the box and whisker plot, the lab's highest weight was 70. So my lab weighed way more. So to find that difference, I'm going to subtract. And we will see that my lab was 55 pounds more than the maximum weight from the box and whisker plot. Okay, state one interval from each breed that represents 75% of the data. Okay, so let's do labs first. If I need 75%, I am looking for 3 sections of the box and whisker plot. Okay, so there's a couple options here. One I could say is from 45 to 65, because that encompasses 3 sections of that box and whisker plot, from 45 to 65. I could have also said from 55 to 70, because that also includes 3 spots, 3 sections, so either one is perfectly fine. For Cocker Spaniels, we can do the same thing. So I could say from 15 to, let's see, it looks about 26. That would be one interval. But I could have also done from 20 to 30. Both of those intervals contain 3 sections of your box and whisker plot. All right, last one here. Is it possible to find the mean weight for each breed? So remember, mean is the average. And so if you think about what you can see on a box and whisker plot, you really need to know every single weight in order to figure out the average, because we would add all the weights together and then we would divide by how many weights we added. But on a box and whisker plot, we can't see each individual weight. All we can see is what the lowest weight was, what the highest weight was, what the middle weight was. So we don't have enough information to figure out the average weight. Now there is one exception. If you have a box and whisker plot that is symmetrical, meaning the boxes are the same size and the whiskers are the same size, then your mean is actually the same as your median. Okay, so that is the one exception. But looking at our box and whisker plots, neither of them are symmetrical. Labrador Retrievers looks like it could be, but one whisker is definitely longer than the other, and so we cannot find the mean from either one of these. So I'm going to say no, because a box and whisker plot does not show each individual weight. Okay, we have one more, and it is a multiple choice. So we need to figure out which statement is true about the double box and whisker plot. Okay, so we're looking at your class versus your friend's class, and these are test scores. So choice A says half of the test scores in your class are between 85 and 100. Okay, so if I'm looking at your class, 85 to 100, it's right there, and they're saying half of them, and that's not true. That actually includes 3 sections, which would be 75%, not half, not 50%. So if they had said 75%, we'd be choosing that answer. Okay, for B, 25% of the test scores in your friend's class are 80 or above. Okay, so your friend's class, 80 or above. So starting at 80 and going to 100, not true. That's actually 50%. So that one's out. Part C, the medians are the same for both classes. Well, for your class, the median is 90, and for your friend's class, the median is 80. So that is also not it. So it has to be D, but let's make sure. The test scores in your friend's class are more spread out than the test scores in your class. So when you're talking about spread, what that's referring to is that consistency. So you're looking at the ranges, and what you can see is that for both classes, the highest score was a 100, but the lowest scores are different, which means the range for your friend's class is bigger than the range for your class. And remember, the bigger the range, the less consistent the data. And so it is true that the test scores in your friend's class are more spread out than the test scores in your class. So choice D is our answer.